Hello everyone, let's go ahead and start. We're going to go ahead and talk about nomenclatures today. Um, Nomenclatures is just another word of saying how to name things. Um, so you might ask, why is that important? Well, how to name chemicals. I can imagine that if you don't know how to name a chemical, you might grab the wrong chemical off the shelf and you could hurt yourself. Or you might not be able to get the correct chemical reaction that you want. Um, if you mistake oxygen for nitrogen, that's pretty intense. So this is so that we make sure that doesn't happen. Obviously not with like oxygen, nitrogen, but some people have mistaken stuff like sodium chloride for hydrochloric acid. One is salt water, or I'm sorry, just salt actually, and the other is hydrochloric acid, one of the seven strong acids. They Strong acids hurt. So we're going to make sure that you don't know how to confuse them, that you know how to name everything, write the chemical formulas for them, and go back and forth. Like if I say something like, I don't know, sodium chloride, that I use that too much. Let's say I don't know, sodium bromide, then you know what that is. You can write the chemical formula for it, and you can do things with it in the future once we, get through the basic stuff. So, nomenclature. Nomenclature. Why is it so? I just told you why this is important. Two characteristics of nomenclatures. This is two requirements that we should have. The first one about nomenclatures is that every name should be unambiguous. Now, what does this word mean? Well, I Googled it because I saw this in a book and I was like, oh, probably should Google this and know what it means. Just kidding, I know what it is. It means it's not open to more than one interpretation. So it's not like, in English where the dog ran, that sentence could be thrown into many contexts. It can be interpreted in like 12 different ways. No, it's simply one interpretation, no more, no less. Um, that's what unambiguous means. The second one is simply having the minimum number of characters in the name. So it just can't be long, be as short as possible, but precise as possible. So it has to be accurate, but also has to be short. So that's kind of hard. Sometimes you got some really long names, so it's fine, but minimum number of characters. So minimum number of characters. If you hear a lot of tapping, it's because I'm sorry. If you hear a lot of tapping like that, it's because I'm on an iPad and I'm writing from there. If it starts to get really annoying, just go ahead and put a comment down below and I will adjust my little setup here to make sure that you guys don't hear that. I don't want you guys to be annoyed by this stuff. Um, okay, so with this in mind, I'm gonna throw out a couple of chemical formulas, and I just want you guys to check. The first thing I want you to do is just kind of sit there and say, how many of these can I personally name? How many of them do I think I know the name of? I won't give the answers to these because we'll probably see them in future examples, but I'm just gonna throw a couple out there. So we have here NaCl, NaCl. I'm kidding, it's not NaCl. Don't ever say that. KBr, BaI2, MgCl2, CaO, and Al2O3. So these are a couple that I kind of want to see if you guys know. What I really want you guys to pay attention to is identify whether or not each of these atoms, you see the atoms here because like the first letter is capitalized. So this is an atom, this is an atom, this is an atom, this is an atom, these are actually two atoms bonded, and this is one atom. So that in mind, I want you guys to pay attention to really locating all the elements in these compounds on the periodic table. I want you to see if you can find them on the table, which hopefully you can. You might be slow at first. It's fine. You'll get pretty efficient at it towards the exam, just because you have to. And trust me, when you get to the exam, you will want to be able to identify where everything is as fast as possible. And once you get like past this test or this class and past 101B, you'll be able to locate things just by imagining it on a periodic table. Like if I say sodium, you'll know exactly where it is. So I want you to kind of locate these on the table. I also want you to pay attention to whether or not these are metals or non-metals. If you don't know what that is, go and refer to your book. We'll talk about them here a little bit, but it's not really too important. I just want to see if you guys can kind of get familiar with these elements. That's the biggest thing. Um, so yeah, now I'm gonna go and write down a couple more, and these I'm actually going to go ahead and write out the names for them, and I want to see if you guys can find the pattern. This is generally how a lot of chemistry students, like for chemistry 151, this is how they're taught. I was taught this way. For some people it clicks right away. If it does, fantastic. If not, I will help you. So don't panic. So the first one is the one that I wrote before, and actually, I think I wrote all of these before. Yeah, I did. Cool. NaCl. So this one is sodium chloride. So, sorry, let me get another pen color. So that's too thin and red. Sodium chloride. Hopefully you can read that. I apologize if my handwriting is awful. You are free to comment below. Next one is KBr. So that is potassium bromide. Potassium. If I spelled these wrong, please let me know. Like, just comment below saying, hey, you spelled this wrong. I appreciate you guys pointing out my mistakes. Don't worry, I don't get mad. Next one is MgCl2. So this one might be a little tricky. You might want to write like, oh, magnesium dichloride. No, it's actually not, and I'll explain to you why in just a moment. But it's actually just magnesium chloride. This is one that teachers like to trick us on. They're pretty good at trying to trick us up. But it is just magnesium chloride. Okay, next one I have is BAI. Oh, it's actually BAI2. What I kind of want you guys to do at this point, just because you've seen 3, I want you to try to pause the video, or just like while I'm writing out the chemical formula, think about what you think the name is. It's okay if you're wrong, obviously. I don't expect you guys to know this already. But yeah, if you guys want to try to think about what this is, it actually helps you memorize it easier. I don't know. Grammar is weird. So this one is actually just barium iodide. That was a hard one to say. Because I is iodine. It's actually just barium iodide. So barium iodide. There's 2 more, so don't worry, we're almost done. Kind of, not really. We're almost done with this, and then we're going to continue to do more stuff. I do apologize if these videos are really long, so don't freak out. CaO. So this one is calcium oxide. So if you're getting these right, that's actually really good. That's pretty much where you should be if you've taken a chemistry class prior to this, or if you're familiar with chemistry at all. If you're not familiar with chemistry, or you've forgotten it, like many people do, it's fine. Most people take it their sophomore year of high school. At least I did, and a lot of people I know did as well. Sophomore, junior year. Don't panic. It's fine. Relax. You're not expected to know this. This is why I'm making the videos. So one more. That would be Al2O3. This one, again, pause the video if you want to try it yourself. This one is just aluminum oxide, or as British people say, aluminium oxide. I wonder how many people I could annoy by saying aluminium instead of aluminum. Aluminum. Cool. So at this point, I would kind of hope that you are able to kind of figure out a pattern. If not, don't worry about it. But try to see if you can find a pattern through all of these. Um, we'll talk about them next. So essentially, I want you to. So here are the questions I want to ask you. The first one is which element is first, and kind of figure out why. Why is it first? I want you to kind of figure out in these cases, like what kind of compounds these are, what part of the periodic table are each element from, um, and if you can find the general properties. I don't expect you to know that by now, but in general properties, I encourage you to find the charges. That's one really important thing. If you don't know about that, don't worry about it until later. I want you to find out. I want you to think about why the elements that are first. Why are they first? Which one is second? Why is it the second one? Um, and essentially, just think about oh, it's Cl2. It appears twice, right? We have Cl2, so that's one magnesium for two chloride. Why is it that we don't write numbers with these? So, kind of want you to think about that. We'll move on to the next set. Or actually, now I'm going to talk about them. So what I'm going to do now is I'm going to pull out a periodic table. I'm going to leave this on the I'm going to leave it on the screen, but I'm going to put a periodic table right here. Hopefully it works. Periodic table. Oh my, this is a large table. Hopefully you guys can see it. If you can't see it, please pull one out yourself. But bam. Okay, hopefully this is visible. But okay, let's go and look at where each element is. So I'm going to use red for this. No, I'm going to use green. Green's fun, right? We can see green? No. Let's use blue. Blue's more fun. Sure, we'll go blue. Okay, so first one, sodium. Where is sodium on the table? Well, it's number 11 on the table. It's right here, sodium. So essentially, what do you think? So I want you to think about where this is in relevance to everything else. Okay, well, it's on the left side. That's it. That's really all I want you to know. And the second one, where is that? Chlorine, Cl, where is that? Well, that's number 17 on the table. And bam. I don't expect you guys to memorize like, oh, sodium's 11 and chlorine's 17. That's not really where you should be. You should just be able to know where they are. Me telling you the numbers, that's just easier for you guys to find them so you guys can count. But no, don't worry about knowing what the numbers are. You're always going to be given a periodic table for exams for that reason. However, I do expect you to know like Na is sodium, Cl is chlorine. These are compounds that we will be talking about every day. Or not every day, every class, and your homework. So I'm not sure if the actual names like chlorine, I'm not sure if this comes up on the exam. So if it doesn't, don't be surprised. But yeah. Anyway, so that's 2, sodium chloride. They're on opposite sides, right? This chlorine is on the right side of the table, but it's not entirely on the left side. Like this one is all the way on the edge. Chlorine does not seem to be all the way on the edge. So I wonder why. And we don't see any in our list that are on the far edge. So that's a little strange. Let's go and move on. So now we have magnesium chloride. And there's 2 of them, but we're going to worry about that later. So, okay, magnesium. Okay, that's not far. That's number 12. Mg magnesium. It's not all the way on the left side. It's like the second to left, the second to far left. And there's chlorine, we have that, number 17. So that's weird. Okay, so if I move from 1 down to here, magically a 2 appears. Is that what's going on? I don't know. Let's figure that out later. Next one, barium iodide. Well, barium, oh, look at that, number 56, right there. It's the second column. So second group, I think. Second thing. And it is, and then iodide is actually number 53, so it's right here. Okay, that's weird. So if I move a column over, it seems that I can put a 2 at the end of the other element. That's kind of weird. Not a rule that I would really want to memorize, so maybe it's not that. We'll see. Next one, calcium oxide. So calcium's right here. Oxide, that's not an element, but oxygen is. So 8 right there, CaO, that works. And it looks as if, okay, so obviously we kind of just come to the point where this is not really used. We don't really touch these. And you are right, you're not supposed to touch them. And we'll explain to you why, and I'll explain to you why in just a minute. So I guess all of them start here and we move that way. So, okay, if it's 1 over, I guess I add a 2 to the other one, right? I'm adding a 2 to the, I'm adding it to the calcium, and then, oh, okay, well, if this calcium is here, the second one over, then I add it to the other side, and that kind of makes sense, right? Ca2O2, and then the 2's just cancel. Maybe that's right? I don't know. I'm just guessing. I'm kidding. I'm just trying to help you think a little bit. I'm not really guessing, I promise. Next, whoop, hello. That's too much. Oh my god. I got rid of like everything. My bad. Okay, whew. Last one, aluminum oxide or aluminium oxide. So aluminum, okay, it's actually not on the far left side, but it's kind of there. It's like the third column. If we ignore all this stuff in the middle, this yellow stuff, then it's technically the third one, right? The third column. So that's interesting. Okay, aluminum's right there, and then oxide's actually on the other side right here. So cool. You know where they are. Hopefully that kind of helps you think about where these are. Let's go ahead and talk about them now. So the idea here is that there is a charge to these. When I told you before that we're going to learn ionic and covalent names, these are ionic simply because they have a charge of positive and a charge of negative. That's a little strange. I know it's not really like, interesting or as good of a guess. Let me go ahead and write this out. So let's use purple. So charges are essentially from these electrons. Electrons have a negative charge or they have a positive charge. These atoms have positive charges when they're deficient on electrons. So if you're less negative, you're more positive. And we'll learn about that later on. Don't worry, relax. What I want you to know for this is fairly simple, just knowing where the charges are. You will use this on an exam, so don't expect you to just have to forget this. This is used everywhere. We use this all the time. So this is a positive 1 charge, plus 1. This column is a positive 2 charge. This column over here, we don't worry about this yellow stuff. This is too much for us to handle. These metals are actually, they have their own charges, and you'll be given those charges if necessary. Boron, and that whole column, has a positive 3 charge. This next column we generally don't really use. It's a strange column. Many teachers teach it as a positive 4. Other teachers teach it as a negative 4. I'm just going to say blah, don't care, whatever. Next column. Actually, we're going to start from the far here. So I want you to think about why we didn't use this column. We didn't have anything there. I didn't put helium or argon or neon or krypton, xenon, radon. I didn't use any of these, or whatever UUO is. I never used those. Why? Because they're actually no charge. There's no charge on them. These are called noble gases from the bottom key that you see from the key below the table. We don't use these in terms of bonding that often. They rarely bond to other things because they're cool. They don't require anything to bond to. And we'll talk about that when we talk about bonds in general. For now, just know the charges. I really don't expect you guys to know anything about bonding just yet, so don't worry about it. So if that's 0, let's go further back on the number line. So we have a negative 1 here, a negative 2 here, and a negative 3 here. Yeah, right there. So that kind of helps. The idea here is that one of these, in an ionic bond, we see one element having a positive charge bonded to an element that has a negative charge. And these come together to make an ionic bond. So let's go and look at this again. So sodium, we see, has a negative 1 charge, right? So we can actually write this as sodium with a positive 1 charge. My bad, that's what I meant. So sodium plus 1 bonded to a chlorine, which is a minus 1. So there's actually something that goes on. It's kind of hard to see with these that have like positive 1s and minus 1 charges, but literally this is what happens. This goes over here, and that goes over here. Simple as that. So you essentially get, I'm going to write this at the bottom over here. So we have sodium 1, chlorine 1. We don't normally write 1, so that just kind of goes away, just to make sodium chloride. That's literally the rule right there. Look at the charges and then just bring each of the, so look at the charges, flip them and just bring them down so that they're sitting and they're no longer a superscript, they're subscript. So yeah, let's go and look at another one. I'll go through each one for you actually, that way you know. Erase. So the next one, whoop, excuse that. Potassium bromide, or KBr. Well, potassium has a +1 charge, so potassium has a +1 charge, and Br, or bromine, has a -1 charge. Oop, -1. So this +1 goes down here, this -1 goes down here. We ignore the chart, we ignore the signs. So we have K1Br1, and that just looks dumb. That looks like commas. I don't like that at all. So we're actually just going to write KBr. Done. Perfect. Next one that we have is, what? Oh, things just kind of, sorry. If things disappear, I don't know. My computer is kind of exhausted. So I apologize on that. Next one is magnesium chloride. So this is where we get like the 2. This is why we get the 2. If you notice, magnesium is number 12 on the table. It has a +2 charge. So magnesium has a +2 charge. So then the next one we have is chlorine or chloride. So chlorine has a -1. So then you might be saying, well, Jay, that just means that magnesium should have the 2, right? Mg2Cl? Well, no, because remember, we are switching the numbers. So this one goes down here with chlorine, and this one goes down here with magnesium. So we get Mg2Cl1, but we don't write the 1, so it's just Mg2Cl. I'm sorry, that's dumb. MgCl2. See, even I make the mistake, so whoopsie daisy. Yeah, MgCl2, bam. And we don't write the 1 for the magnesium, so yeah. So you could write Mg1Cl2, but we're going to look at you weird, and it might be wrong. Who knows? So just don't write the 1, so MgCl2. That's it. Sorry about that, guys. I didn't mean to make that mistake. I promise I won't do it again. Don't like kill me. Next one, barium iodide. So barium is number 56 on the periodic table is Ba. That is a +2 charge. So Ba +2 with iodine, which is, or iodine, whatever the hell you want to call it, whatever the heck you want to call it, sorry, is number 53, and that is a -1. -1. So again, we just bring the charges down. I know this is a little repetitive, but hopefully it sticks in your mind. That's what I want. They go down there, so we get BaI2. That's what so essentially that is, barium iodide. So essentially, if I told you, let's look at something like strontium bromide. Well, strontium is Sr. Bromide is, or bromine is -1. It's number 35, sorry. Sorry guys, I'm like really tired. 35. So you know that Sr has a +2. I'm not writing this one down, I'm just telling you, so don't freak out if you can't see anything. Sr has a +2, Br has a -1. Immediately you can say, okay, we'll drop the charges, switch them, so you have Sr, Br2. Done. So the question is, in calcium oxide, pretty simple, except it's not. So you would think that, calcium oxide, each one has a +1 charge and a -1 charge, right? Actually, no. That is not right. So look at where calcium is. It's number 20. It's a +2 charge, right? So calcium is a +2 charge. Oxygen or oxide, oxide when it's bonded, oxygen when it's not. Oxygen has a -2 charge. So that's weird. Technically, when we drop the charges and move them, we remove them and drop them, yeah, we get Ca2O2. Okay, well, that's not what I have written there. Why? Because we can actually, almost like fractions where we cancel them out, put them to the lowest terms. Same thing here. We can drop it to the lowest terms. So that's just CaO. We can just remove this. So this is equivalent to CaO. And this is more correct. If you write Ca2O2, that means that you have not fully learned this concept, and that, when you put that on an exam, we're going to see that, oh, you didn't really learn this concept all the way, so it's not entirely correct. So, yeah. Last one, aluminium oxide or aluminum oxide, wherever you are from in this world. So aluminum has a +3 charge. So now we're getting into the threes region. So aluminum +3. Oxygen has a -2. So like normal, we just put them over here, switch them around. You can draw the arrows if you want, really, that's how I do it. So then we have Al2O3. So that's where these numbers are coming from. And we're not just magically giving this molecule, two aluminium with 3 oxygen, and just boom, it bonds. No, it's more just, okay, we're looking at the charges. So this is what they want the chemical formula is versus the chemical name. So hopefully that makes sense. Go and move on. So also people have a question with is, why do we call it, so for sodium chloride up here, why do we call it sodium chloride and not sodium chlorine? So essentially the question is, why is this "ide" here? Well, it's really just for it to sound more correct, and that way you know that chloride is the last thing written. So it's not sodium chlorine something else. It's sodium chloride, done. These are called analogs. So chlorine has an analog that's called chloride. Bromine has an analog of bromide. Iodine has the analog of iodide. Oxygen's analog is a little different. It's oxide. You'll learn these as we continue. Sulfur is a sulfide, fluoride, nitride, I think. Yeah, phosphorus is a couple, including phosphate. There's a few, and you'll definitely learn these as you go. But for now, just know that, honestly, what I do is if it's in this row, predominantly, you just kind of put an "ide" at the end. That's really it. There's not really anything else to it. It's really just about the pattern. The first one does not get anything, so it's not sodiide chloride. It's sodium chloride. So that just kind of knows that, oh, sodium is written first. Doesn't it doesn't sound different. So okay, it's the first one. Chloride, okay, so it's just NaCl. Done. So that's really it. Let's see. Sorry, moving on. So I'm going to go and actually give you a couple. I'm not going to write the answers to these, but I'm going to write down the formulas for them, and then I want you to pause the video and try to figure out what these are, and then unpause the video. We can, talk them over. So, and I'm gonna remove the periodic table. I want you to look at your own with the charges. So let's go. Let's do Li, I. That's a little weird. ZnCl. 2 Na2O, that is an A, by the way, AlCl3 and Al2O3. I know we just did a couple of these, but just try them again, see if you pay attention. Go ahead and pause the video now, and we'll go ahead and talk about the answers right now. Okay, we're going to go and go over the answers. So the first one, Li, that is lithium iodide. Next one is zinc chloride. Next one is sodium oxide. Next is aluminium chloride or aluminum chloride. And last one is aluminium oxide or aluminum oxide. So hopefully no one wrote dichloride or trioxide. No, that's not right. Not for ionics. So for ionics, there's no number thing, no di, penta, hexa, octa, no. It's just lithium iodide, zinc chloride, sodium oxide, aluminum chloride, and aluminum oxide. Bam. So these are supposed to be a little easier than the next one I'm going to talk about. So hopefully that makes sense. If it does not, please go and ask your questions below. Bring any examples to us in office hours. If you can find me, Jay, preceptor, hello, in class, go ahead and just ask me, what did you mean in this video? I make the videos, so I know what I mean. Other preceptors, some of them don't watch these videos, so I wouldn't expect them to know it. You can ask them if you have like an example, but if you're just gonna talk about like, oh, in this video you talked about this, what does it mean? Um, they might know it, they might not. So look for either Dr. Van Dorn or myself. Most likely we'll know it. Let's see. Next one we're going to go over. So we went over ionic compounds. Now we're going to go over covalent compounds. So ionics, I'm going to go and put a periodic table up here for just a second. Boom, periodic table. Hopefully that didn't scare you. So with ionics, we talked about, stuff here that bonds to stuff here. Well, that's fine and dandy, but okay, what if it doesn't want to bond from here? What if we don't have these? If there's one here that binds with another one from here, well, that's a little awkward. They have different rules. They're not the same rules as ionic, they're a little different. In these, we don't look at charges, which is kind of nice. If you don't really like charges, we don't have to look at them. This one, we just look at numericals. How many of each do we have? These are called covalent or molecular compounds. So, yeah. So I'm going to write out a couple. See if, for now, I just want to see if you guys can name them, and then we're going to go and talk about them in the next, minute. So, first one is NO. No. Next one is NO2, NO2. Next one is N2O. Next one is N2O3. And the last one, which is N2O4. Sorry, that one's written a little on the side, but yeah. So, go ahead and think about these. How do you think you would name them? And then we're going to go and talk about them. So, I gave you some time. Sorry about that awkward silence. I just kind of wanted to read something. I got like a notification on my phone. Sorry. Don't have your phones out in class, by the way. Phones are bad. Stop it. Anyway, continuing on. So I'm going to go and name these for you. You might get the pattern. You might not. I'm not going to write these out because it takes a little too long. But I'll circle them as I name them. So this one is dinitrogen oxide. Mononitrogen oxide. Wait. I think it's just nitrogen. Yeah, sorry, nitrogen monoxide. That's what I meant. I'm sorry, guys. It's been a while, and it's really late. Sorry. Nitrogen monoxide. That's what it is. Next one is nitrogen. This one. Nitrogen dioxide. Next one is dinitrogen monoxide. That's the one I meant. Dinitrogen monoxide. Next one is dinitrogen trioxide. And this last one, I don't like saying tetra, so it'll be, sorry if I stutter, dinitrogen tetroxide. Tetroxide? I'm going to write this one out. Dinitrogen. I can't write for crap today. Tetroxide. Yeah. That looks really bad. Sorry, guys. Okay, cool. That's the only one I'll write. So, hopefully you guys can get the pattern from this. There we go. If not, we'll figure it out in a second. So I'm going to go ahead and go over a couple more. But first, I'd like to ask you, what do you think you guys drink every day? Or I would hope you drink every day. It's summer in Arizona. If you don't drink it every day, please, for the love of God, go get some right now. You're probably severely dehydrated. Actually, now I want water. Awkward. Okay, water. H2O. What do you think it's called? Well, besides water, obviously, it's actually dihydrogen monoxide. So, yeah. By the way, fun fact, everyone that is exposed to dihydrogen monoxide die. 100% of people exposed to it die. If you understand that joke, please laugh. If not, ask a friend. Anyway, so we don't really call it dihydrogen monoxide. Not really. I mean, yeah, it is called dihydrogen monoxide, but we have more simple names for that. And there are the common names, like water. if you ask your mom, can I get a cup of dihydrogen monoxide? One, I don't know if they'll know what that means. If they do, they're going to stare at you and say, why? Why are you saying it that way? You're going to sound a little funny. So yeah, I'm going to go and write a couple out now. I'm going to see if you guys can kind of figure it out. So if I write the name, I want you to give me the formula. If I write the formula, I want you to give me the name. So we'll play a little fill in the missing boxes kind of thing, except I don't have boxes to fill out, kind of thing. So, name, formula. I can't write for crap today, and it's kind of annoying. Okay, so the first one, it will be a formula. So BCl3. Second one is going to be a name. Dinitrogen pentoxide. Next one is PCl5. Right? 5? Yeah, 5. And then last one is a name, sulfur, which smells delicious. Not really. Tetrafluoride. So go ahead and pause the video. Sorry about my really bad handwriting. Just because it's an iPad. I promise I'm not really that crappy at writing. Go ahead and give me... So essentially, I'm going to highlight in red what I want. Or in green. Green. Let's go yellow. I want you to give me this, 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 and this for each one. So, like, essentially, give me the name of this. I'm sure you guys can figure it out. Okay, so go ahead and pause the video. Do this. I expect you guys to do this, please. If you don't, it's not going to help you. So, yeah. And then go ahead and pause it, and we'll go ahead and start the video and start the answers right now. Okay, so I'm not going to write these out again. I'm just going to go ahead and tell them to you. But hopefully, actually, the formulas I'll write out, but the actual names, they take too long. So I'll just go and say them. I'll go and say them a couple times. Yeah, okay, so the first one, BCl3, it's just boron trichloride. So one of the things that people have done is they'll write monoboron trichloride, as I said accidentally a couple minutes ago. No, so for the first element, you don't write mono. If it's just one, it's just that element. Like the next one over, or we'll talk about it in a minute, but yeah, like boron, it's not monoboron trichloride. That sounds dumb. It's just boron trichloride. Simple as that. Also with that, so if you have something like CO, that's carbon monoxide. This O over here has the mono on it, but the carbon before that does not. By the way, carbon monoxide is very deadly. Do not stay in a car in the garage. Please turn off your car when you exit the garage. Yeah, that's how people die. Anyway, next one, dinitrogen pentoxide. Did I write this correctly? Yeah, I did. So this is just N2O5. Nope, that's badly written. Dr. Van Dorn, freak out. Let's go and fix that. 5. N2O5, dinitrogen pentoxide. So I want you guys to know these prefixes like mono, di, tri, tetra, penta, hepta, hexa, octa, nona, deca, undeca. Undeca's 11, by the way, if you weren't, going on with that. Most likely we won't see stuff like, 11 or 12. Like maybe 10 is maybe where we'll stop. I don't know. I personally would never give you like O. N, O, 20. That's crazy. Are you kidding? First off, I don't think that would exist. But also because that's really terrible. Next one, PCl5. So that is phosphorus, not monophosphorus, but only phosphorus pentachloride. So remember that we still end with ide, pentachloride. So that part of the ionic bond rule we've kind of taken with us. However, we just call it phosphorus pentachloride. So phosphorus pentachloride. By the way, if you've noticed, if you guys watch this stuff like on mute, which I know some people will, they're obviously not understanding what's going on at the moment because I'm writing absolutely nothing for this stuff. So you must listen to these in order to learn things. Next one is sulfur tetrafluoride. So notice how it doesn't say monosulfur, it just says sulfur. So that's just sulfur and then tetrafluoride. So that's fluoride, but how many? Tetra, 4. Done. Easy enough, doesn't seem too bad. Um, so there are a few binary names to stuff that we don't say, like hydrogen monochloride or HCl. No, we don't have a name for this. We just call it hydrochloric acid. These are other names we have created for these compounds because they're very important and very widely used. Like dihydrogen monoxide, we just call it water, or else everyone would be calling it that and no one would know why, and it'd be the funniest thing ever. Um, anyway, moving on. Um, That's really it, actually. I'm going to go and talk a little bit about these binary names, weird names that we don't really work with. Stuff like, HCl, HF, HI. We don't really use like hydrogen chloride, hydrogen fluoride, hydrogen iodide. We have other names for these. Like this one's hydrochloric acid, hydrofluoric acid, hydroiodic acid. We have other names for these because they have other purposes. And we will definitely use these other names very frequently. So if Dr. Van Dorn says hydrochloric acid or hydrochloric acid, do not sit there and say, what the hell is that? Just say, okay, well, it's on the PowerPoint, HCl. And that's really it. So that's really it for this video. Not really too much going on. We talked about ionic. We talked about covalent. That's really it. We got introduced a little bit to the charges of the periodic table, so I'm glad you guys know that now. What's the next thing I really want you to do? Well, it's this. Practice, please. When you get stuff in the book, like look in the book, look at some of the names, and just kind of say, okay, well, let's see, NO5, 5, or N605. Let's say that exists. Not really, but then you'd be like, okay, well, that's just, whatever. Like, name it. So try to name these. Try to, practice this up. If you think you miss anything, go back to the video. It's obviously on YouTube, so you can go back to it. Okay, before you leave, I would like to encourage you, one, to rate me. So rate the video. Please rate. Whoops, I just did something. Rate how I essentially worked, how I talk in the videos, and also rate the video itself. Like, does the video have good quality? Blah, 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 blah. So rate me, whoops, / the video. Go ahead and comment below, either saying thank you, I liked it, or oh my god, you're a horrible video person, or I didn't really understand this, please explain. You are free to ask any questions you wish. If you're the type who does not like confrontation, hold on, comment. If you don't like confrontation, you don't like everyone publicly knowing what your question is, because some people have that fear, like, oh, I don't want anyone else to know what my question is because I think that they're going to think I'm stupid. Well, no, first off, everyone might have this question. Believe me, not that many people get this stuff pretty quickly. So that's why I told you guys to practice. If you guys have any questions that you want to ask me personally, feel free to email me. My email address is up on D2L in the announcements area. My name is Jay Patel. Hello, that's me. Feel free to email me. Just say, oh, video 2, nomenclature question, and then go ahead and, well, first off, tell me who you are also, because I feel like if someone emails me, I might think it's one of my preceptors for another class, or I might think it's an actual teacher, because I still don't know who my teachers are. That's kind of strange. I don't memorize people. I'm a bad people person. But no, just tell me, like, 101A question, video 2 question, and I'll be able to answer your question right away. If you put it on the comments, I will happily answer them. Please go ahead and comment. That way I know to answer your questions. Other than that, not really much here. Oh, also, please go ahead and subscribe to the channel. This is the chemistry channel. This is where we post all the videos. If it's a video that I make, it'll be posted here. If you subscribe, most likely you will know when I post the next video. You'll be updated. You'll be told, okay, well, this person, Jay, just, posted a new 101A or 101B video. Do know that you will get notifications for the 101B stuff. If you're curious and have time, sure, watch them, whatever. They might confuse the crap out of you, no doubt. However, just know that some of the videos might not be for you. They might be for 101A or for 101B. So just go and take a look. I would definitely bookmark the website if anything and just check back. Most likely I will have Dr. Van Dorn make an announcement, or just check back, no promises, but please subscribe. I can't spell. Because when you subscribe, that tells me that you're watching the videos, not by how many views I get. Really, it's about how many thumbs up / thumbs downs that I get, as well as the thumbs up, thumbs down. I won't feel bad if you give me a thumbs down. Please be honest. If you don't like the video, please tell me why. You're free to email me. I will not report you to the dean. Not that I could if I wanted to anyway. Just give me constructive criticism to help you improve learning. That's my job, and I want to make sure that you guys are able to understand things. But the way I know that you watch the videos is if you guys, thumbs up me, like, when you rate, you either put a thumbs up on there or you put a thumbs down. If you comment and if you subscribe. If I know that you're doing that, then great. The videos will keep on coming. I'll happily make them. If you guys aren't watching these, well, clearly I'm not making them. That's how it works, essentially. If even one person's getting a lot out of this, that's all I want to feel good. However, it takes a lot of time out of my day, so I definitely want to make sure that you guys are, doing well with these videos. If they're actually helping you, get your friends to watch them. If they don't get something and there's no office hours on a certain day, like on Saturday, watch the videos. Thank you everyone for watching. Go ahead and have a great night, and I'll see you guys in class.